Hello guys, good evening. This is Gisa Emmanuel, the director and the head of research at Brilliant Researchers Africa. We would like to present some of our byproducts that we have gotten from different experiments that we have recently conducted about modern plastics. So in recent days, we were conducting different trials about different types of plastics and polymers, whether to see their covering bonds and how to hold each other's. Once the monomers and polymers are mixed from different properties, how it reacts and what it produces. Okay, let me get started by starting from the bottle caps. The bottle caps that are used to seal the bottles of different things like water, like the other those yogurts and the other different things that we usually use in real life. So if you can see this one is the byproduct from the experiment that we have conducted. So this one was obtained from the bottle caps. You can see it is very, very strong and it's very compacted. If you can see it, as you can see it right here, it is one of the best and amongst the best that we have gotten from the trial experiment we have recently conducted. Where, as you can see, you can use this one. Once you transform this one, you can use it in different ways, and it is by itself creating different color pigments. You can sometimes think it's a dye that we have added in this byproduct of the bottle caps, but it is not. It's not only this one. We have tried to different plastics like a polyvinyl chloride. We have tried the propylene, the PET, for those with high and lower densities. So as I have many colleagues that we are working together with this, I'd like to share with you some of their overviews and how the experiment went. Thank you very much.
Good evening, I'm Yvonne Owera. I'm among the team of Brilliant Researchers Africa. I'm going to explain the binding mechanism among our plastic. I'm going to explain about how sac can be made something which is strong by heating and melting them. Here I have our product from two cement sacks. Here we took the two sacks and we mixed them and we heat by the temperature between 130 degrees Celsius. From 130 degrees Celsius, they start to melt and they give this product. Here you see this is too strong. They can make different things especially in construction. You see it is too hard and too strong. This is our product from, and we saw that a cement sacks can give us the good product because it is hard and it is strongest one. Thank you.
Okay. Quick question. What is the problem are you going to solve from the society? That kind of sacks for cement sacks? Why did you choose to collect it and make some strong materials like that you want to use in the construction? And so why did you have that invention from that?
The first one, these sacks give the product that is strong and it is waterproof. They resist to the water, and second, they reduce the problem of waste management in our society.
Thank you.
Welcome.
Hello guys, I'm here by the names of Waseli Diane. I'm the one of the group which is doing research from the Brilliant Researchers Africa. We have conducted research on molten plastic, and here I have one of the products that we are dealing with. This is PE we made it from white basket. Yes, it is very strong, as you see. It is waterproof. It can be used in construction, and it can be used as one of home tools that we even used or will be using in the future. This is going to solve the problem of waste management. As you see, the society is challenged by plastics that cause.
Okay, Lilian, so can you please tell us why have you just tried basket? Basket is usually used in different activities to help people to carry something and many things. So why would you choose to recycle those baskets?
Those baskets, when are not in use, they are containing water, which can be source of disease, which can be spread into society. And those baskets are going to be recycled in melting them and producing new products from them.
Okay, thank you.
You're welcome.
Okay, as you have seen different types of plastics that we have conducted and tried in the research experiment, I would like to present to you one of the mechanical engineer who refers to designing and many byproducts. Actually, after trying different trials and doing different experiments, we have come up by the byproducts. So I need him to introduce himself and let us know about those byproducts we have got.
Yeah, I'm here by Nirajire Ramaorase, and I'm the one of the team in Brilliant Researchers Africa. We are doing an experiment, and now we get something. We get the brick. You see the brick? That is from molten plastic and the sand only. We use the molten plastic as binding material, then it's bound to form this brick. That is strong and too hard enough to build your house, and will be eco-friendly, and we will manage the waste and the society. As you know, the problem of plastic, so we are solving it by recycling the plastic, melting it. This is a bottle, molten bottle, and mix it with the sand to get this brick. So.
Okay, Lama, so thank you. I've seen a very interesting and impressive project that you are head of. So I would like to ask you one question about this. Why have you chosen to make bricks, and what are the uniqueness of your bricks comparing to the existing ones?
Yeah, we chose to make a brick because it's used to make our shelter, and as we know, we need the house and the shelter every day. It's a basic need of human. So we make this brick made in metal and plastic as binding material. That's the uniqueness of our brick. Is binded by a molten plastic only. We don't use the cement, and it will be lighter weight compared to the one from the cement. Yeah, that's our uniqueness.
Okay, thank you very much, Lama.
You're welcome.
Okay, as I have previously represented different researchers in different fields that we are working together to transform Africa's pressing challenges and bringing the innovation through our pioneering research. Brilliant Researchers Africa would like to present to you our next research who works under the polymerization and organic chemistry. So let's welcome her and let us know what the difference between the polymers plastics that we have used to get different bonds and bind and all those byproducts. Please.
Thank you. I'm Cynthia Ilasemba. I'm chemistry researcher here in Brilliant Researchers Africa. As they have continued to say it, we are doing recycling in plastic with different types of plastic. Here I'm going first to present this one. It is composed of different plastics: polyethylene, polyester, polystyrene, and others. As you can see, there is no binding between these plastics. It means they have different properties which make them to bind differently. So during the research and experiment, we have concluded that we are going to make different plastic depending upon their properties. As you are seeing here, in middle there is kind of plastic which are not mixed completely with others. So to solve this problem, I think we are going to make the plastic differently or separately as the solution. And we have here different plastics. For my opinion, as the comparison, here we go with the first type, which is composed of polystyrene as polymer. I can say that this is the strongest one we have made. And for the second, we have this one. It is also polyester, which has cement sacks. Here was the boros caps, and here we go with cement caps. This is the second strongest material we have done in our experiment. We go with the third product, which is composed of thermoset plastics, but it is also polystyrene in nature, and I can rank it at third level. It is composed of bucket. It is composed of bucket plastics. Those plastics that are used to make bucket at home. Those we use at home. And this is the last one. This is composed of boro, LPT, and PS. It is the mixture of those plastics. As you can see, it is more waterproof than what I'm going to show you next. And it is like that. It is like to fourth. Here we have also the one which is the boro plastic with sand. It is heavy because of sand. It is more heavy, and it is waterproof, but it is light. It can be broken easily. And the last one, this is the last one. It is composed of much sand and the bottle plastic as binder. It is like the last because it absorbs more water. We haven't used the cement here. As you can see, the water just falling off. It is like the last cause of that.
Okay, Cynthia, thank you for presenting to us different types and how we have obtained that one. So please, can you tell us what's the innovation in those projects and what is gonna be used for? So as you can make someone feel interested about the byproducts that you are going to produce.
By innovation, first of all, there is more usage of plastic. Those who make recycling, they're just making other things, not a construction materials. Here we are just performing construction materials, and we are giving them more qualities like waterproof and others, and strength. So I think for our project, we are just.
Okay, Cynthia, it was an interesting to present to us those kind of plastics. So I can see that will be no waste of bottles and the other plastics that is going to harness and amaze the cities, the countryside of Rwanda and Africa, as you have a big project that is going to benefit in many different sectors and aspects of life. So it was a nice ideas and a very good one. We wish you a courage.